Hey guys, welcome back to my series on restoring classic late 40s American black and white electrostatic televisions. In this series I'm going to be pointing out some of the differences between these sets and the more common magnetically deflected sets, give you some tips, some tricks, some suggestions, some pitfalls to avoid to get these up and running. I finished the recap. By that I mean I've replaced the remaining paper caps and the electrolytics and the power supply. Here it is with the original picture tube reinstalled. We still have horrible interference, but I found the source of it. I should know better. I've seen people post in online forums on Facebook again and again that they have problems with their image like this or other issues with smearing and tearing and rolling and weird interference. Always do two things. One, you try a different signal source, be it an over-the-air converter box, RF modulator, or whatever. And the other is try a different channel. So I was using channel 4 all this time. Let's try channel 5. Hey, the interference is gone. So I discovered by trying channels 2, 3, and 4 that they are all kind of messed up to some degree. Now this type of tuner has an individual slug that you can access through a cutout in the front to tweak the local oscillator slug for each channel. It's down around where the slot is behind the fine tuning. You can put a tool down in here and tweak it. They must all be off. I've tried channels 5, 6, 7. They're all fine. So I'm glad I didn't spend a whole lot of time probing and injecting and scoping it out when all the time the problem was just a misaligned tuner. So I will go back, and I'll show you, and we'll do channels 2, 3, and 4 and get those working better. But there we go. Alright, let's try to fix up channel 4. So let's go from 5 back to 4, feed in a signal on 4, and there is our horrible interference. Now you're going to need an alignment tool to feed down in there. It's a brass screw you're going to need to adjust. Don't use a flimsy alignment tool made out of ABS plastic because the tip will just break right off of it. Use something ideally that's fiberglass. It's tough. You can file or sand a flat-bladed screw head onto a fiberglass rod. Don't use metal if you can avoid it because that's going to affect the tuning. So it'll affect the capacitance and inductance of the circuit. Alright, so feed it down through this hole and you can feel it ideally engage in the screw head and start turning. I think I'm going the wrong way because now we have nothing. So let's go back the other way. And hey, how about that? Our interference is gone. Now I suggest you do this with the speaker hooked up and sound so you can make sure you're getting good sound. Now speaking of sound, one thing about these sets, because they're lower cost budget sets, I think everyone I've ever worked on had inter-carrier sound. That seems to be the norm. What do I mean by that? I mean that the sound and the video IF share the same IF circuits. With that arrangement, generally means if you have a good picture, you have good sound as well. The other type is split carrier, where right on the output of the tuner it goes into two separate IFs. If they get out of alignment, that's how you can get a good picture and bad sound, or vice versa. But generally with these sets, if the picture's good, the sound will be good as well. So, that takes care of the interference problem. Well, let's have a little fun. Some of you may remember the opening segment of this series when I showed a gigantic 12-inch electrostatic CRT. Let's try to get it to work. This is a 12 FP7. I got a couple of them from Fair Radio Sales, which recently went out of business way back in the 80s. I think they were $5 or $10 a pop. Now, up until recently, I didn't have full data on these. The only thing I had was a pinout from a compendium of cathode ray tubes. But I recently did a web search and I found the full data sheet for it. I'll share it with you in a moment. It turns out that this has more elements in it than a 7JP4. It has, I believe, 3 anodes and 2 grids. One of the anodes is this sticking out the top, just like we have with the 3JP12, and it turned out that if I didn't connect it to anything, it seemed to work okay, so that's what I'm going to try doing. The extra grid on this is normally going to a pin that's unused on a 7JP4, but it should be similar voltage to the pin right next to it, so I just shorted 2 pins together on that. Let's give it a try. Now, this is P7 phosphor. It's 2 types of phosphor, and you can actually see on the face of this, one phosphor was sprayed on. It's the overspray around here, and then there's another phosphor in here. One is short persistence blue-white, the other is long persistence yellow. I use these for radar, so you'd get a sharp response for a rapidly moving object, and you get the long response to give you kind of a tracer. Okay, I'm not seeing anything. Let's turn the brightness up all the way. Ah, there is something there. Contrast up. Looks like we might have lost horizontal sync. Ah, there we go. Okay, so it is producing an image. Really off center. As far as I can get it, I wonder if CRT might be perfectly symmetrical with the deflection plates. Horizontal. There we go. Oh, that is freaky. I thought it'd be brighter though, because we're putting out enough high voltage. It's definitely within this thing's operating range. Let's turn the contrast down. See if I can focus any better than that. So if you there we go. If you get a 3FP7 or another P7 phosphor CRT you want to use as a bench test CRT for these electrostatic sets, yes, it can be done, but this is the kind of image you're going to see. It's certainly fine to see if you have a raster, if the set's working, but you're not going to want to use this to make fine adjustments. Let's go to a fixed test pattern. I think that'll illustrate the effects of the persistence more. Well, that's freaky. It's making like a weird singing sound. You can see when I change patterns, that blue-white changes very quickly. So if we had one that was made with that phosphor, I'm not sure what it is. It might be P2 or something. If we just had that, this would be way more useful as a TV. Oh, interesting too on the edge. Let me get this back so it's really going off the edge of the screen. So there's overspray where they use just, so you can see just the blue-white phosphor on the edge. And then you can see where the yellowy stuff starts. Right around in there. But here, yeah, that's just the one phosphor. Huh. And actually for a static image, it kind of looks like a black and white image. It's not until something moves that you get that long persistence phosphor kicking in. It makes it, well, unwatchable. Like that, right there. That's not so bad. But when they cut scenes and things change, yeah, like that. That's a problem. But hey, Might be the world's only 12-inch electrostatic TV. And I actually do my way back when, in the 30s, did make a 14 and a 20-inch electrostatic television picture tube that they used in some of their pre-war sets. There's one at the Early Television Museum. I think it is a 12 or a 14. But it's not working. Those picture tubes are really, really hard to come by. I've never seen one outside of a museum. But hey, we got a 12-inch electrostatic set going here. Alright, that's going to be it for now. I think in the next installment, we may be able to wrap up this series. That's it for now. Thanks for watching. So the set is off now. I wonder how long that's going to stay on there.